Okay, so good morning. Today we are supposed to see switching. So in this switching, we are going to see first what are the contents of your Ethernet frame. An Ethernet frame will have all these things, especially the start of frame, the destination MAC address, the source MAC address, the type of data, the payload, the data inside it, and the frame check sequence that has the cyclic redundancy check. Now, this is about the preamble. This is about the start of frame. The important thing for us is the destination MAC and the source MAC address of the devices. And these are the type of networking device that we are supposed to know. This is the device that we will be discussing today. It is an Ethernet layer 2 switch. And this is a multi-layer switch. Multi-layer means it can be a layer 2 switch or a layer 3 switch. Now, if you remember, carrier sense multiple access and collision detection. CSMA, CD technology earlier, CSMA CD. Carrier sense multiple access and collision detection. In older devices, collisions used to happen when two devices transmitted simultaneously. If I say there are two devices over here and they are connected to the same segment, and these both devices want to transmit, they will check whether the media is free. If the media is free, then they will transmit their data on the media, and sometimes the collision used to happen and there was a jam signal that was generated. We saw all the sequence earlier, but now to avoid collisions, we had Ethernet bridges. Your Ethernet bridge will be is shown like this in your diagrams. It is kind of this, you can say. This is how they will represent an Ethernet bridge. An Ethernet bridge, what did the Ethernet bridge do? It used to separate your collision domains. So collision happening in this part will not affect this part. This part is the place where the collision happened. This is the network segment where the collision happens. This is the place that is not affected. So Ethernet bridges used to separate these collision domains. So what they did was they created a more intelligent device. Just assume that your Ethernet bridge has a software, and what is the job of the software? To learn the MAC addresses and to forward and to separate the collision domains. Now, your Cisco devices, if you say, they have something called an ASIC, that is application specific integrated circuit. Just assume that that bridges software has been written on a chip and this chip is placed over here. So if I say there are 48 ports on my Ethernet bridge, this is also called as a multi-port bridge, because bridge is the switch is the predecessor of a switch is an Ethernet bridge. So people will use bridge and a switch, these two terms interchangeably. Someone will say it is a switch, someone will say it's a bridge. It should mean Ethernet switch only, because we are not using bridges anymore in our enterprise device networks. So if I say a bridge used to separate a collision domain and I have 48 ports on a bridge, how many collision domains do we have? 48 collision domains. Because understand, this is like one bridge. A collision happening on this point will not affect on this port. No, actually you will connect n devices over here, but sometimes you can also connect a networking device, a hub over here, and using a hub you can pull this design like this also, but we won't do that. In enterprises we should not follow this design. But if you have a collision over here, because hub is a half duplex device, you can say a collision can occur over here and here, but this collision will not be propagated over here. Getting the point? So an Ethernet switch, now these switches are also called catalyst switches. Why? Because the term in science about catalyst is, a catalyst is a one who is a part of reaction, but he does not do anything in the reaction. It's like water. If you have water, it will not change anything. It will be in the reaction, but it will not do anything to any changes. Your Ethernet switches will take the frames and they will just forward them out. They do not change the components of your frame. But your router will do some changes in the IP packet, you can say. In the frame also, it changes the source MAC and destination MAC. Layer 2 rewrite it will do. So getting the basic idea of an Ethernet switch, this is a layer 2 switch. By layer 2, I mean to say it is going to understand your MAC addresses. Getting the point of it? Now, remember address resolution protocol? If this is my PC A and this is my PCB, these are the MAC addresses and this is the IP address. Both are in the same network segment, and this device wants the physical address or the hardware address or the burnt-in address or the MAC address of this device. What does this device do? This device sends out a broadcast, right? Broadcast is received by all these devices, and the guy who is intended will give us a reply. Recalling address resolution protocol. These are my two devices over here, and I connect my devices like this. And if I say I have a PC with an IP address of 1.1.1.1, MAC address of A, 1.2.2.2, MAC address of B, and 1.3.3.3, MAC address of C. If this PC over here on the same LAN segment wants to communicate with C, but he does not know the physical address, then he sends out a broadcast on the network. This broadcast is received by both the devices, and the intended device will give us a reply. Getting the sequence? What was the sequence? Receive complete frame, validate the frame, check whether the target MAC is my MAC. If yes, then process. If it is not for me, then discard. This device here we were using was an Ethernet switch. A switch will send broadcasts, right? So what we say is a switch separates your collision domains, collisions, but it's a one broadcast domain. Because now if I say a switch separates collision domains, means a collision happening on one port is not propagated on the other port, right? But a broadcast has to be sent out, right? So if I have, so which is the device that will separate my broadcast? This is one big broadcast domain. And if I have a router connected to somewhere, then this router does not send a broadcast receive on the other side. A broadcast is not propagated. Getting the point? Once we do DHCP relay, this guy, there is a server over here, and this guy wants an IP address from the DHCP server. He will send out a DHCP broadcast to this router. At that time only, if you tell the router to send that, this router will send, or else never a broadcast is propagated outside your network. Your switches have the three major functions of your switch are: first is address learning. What address learning? MAC addresses learning. Second is to do the forward or do the filter decision, to decide whether to forward or not to forward the frame, and then is to avoid loop. The three major functions of a switch are address learning, frame forwarding, filtering decisions, and loop avoidance. We'll see these two first, and then we'll move on to the third one. So if I say I have an N device over here and an N device, these two devices are connected to my Ethernet switch. This device, we will only talk about the MAC addresses over here because this is a layer 2 switch. The moment the frame enters your switch, the MAC address of the switch of the N device is learned and kept in the MAC address table. You can say that. There is also a table called TCAM table, ternary content accessible memory. But as of now, just we are new, so we'll understand that there is a MAC address table, and with the first frame entering the switch will learn the MAC address of your frame. What is the MAC? The source MAC will be recorded. So you will say, okay, I have on my first interface There is some field over here. As of now, we will not see that. Just assuming there is something over here. But I have Mr. A sitting on my fast Ethernet 0/1. Right? If A sends out a broadcast, this broadcast has to be sent out on all the other interfaces except the one which I have received. Now, this guy sends out a unicast. The moment he sends out a unicast, the switch will update its MAC address table. He will say B is sitting on my F0/2 interface. Like this, it will update the MAC address table. And by default, the aging time of the MAC address is 300 seconds. It's going to keep the MAC address for 5 minutes in the MAC address table. If these devices are not communicating, it will flush the MAC address table. Getting the point? This switch is also called as a plug and play device. Means nothing has to be done. Just plug the device, add the PCs, and you are good to go. Let us see a very basic operation of our switch, the address learning function of the switch. How do we see whether the switch is learning or no? So let's go in here. Let's take any switch. Try to take these numbered switches. And what we will do is we will simply connect this device over here. And see, without any extra configuration, like on our routers, we had to configure our switch ports as no shutdown, right? Those were our layer 3 interfaces. They are off by default, but your switch, this guy will turn it on without any special configuration. Now, as of now, this switch also has an iOS. So I can also see enable show MAC address -table. This is the command to check the MAC address table. As of now, there is no MAC address learned, right? Now, if I send out, if I give an IP address over here, 1111, the moment I hit a tab key, a GARP is sent out, a gratuitous ARP is sent out. With the GARP being received, the switch will learn the MAC address. The switch, if you say the PC is over here, he is not communicating with anybody, but with the moment we say we hit a tab key over here, this guy sends out its IP and MAC, you can say, and he checks whether there is an IP address overlap. So that is the reason a frame comes into a switch and the switch learns the source MAC address of your end device. He says this is learned dynamically and this is on my F0/1 port. Getting the point? Okay, now what we have to do is, the scenario says I have two departments. I have two departments, and these two departments, for example, if I say that this department has to be in, this is a purchase department and that is the sales department. Wait just a moment. This is my purchase department and this here is my sales department. I want these people to be separated from these people. What is the solution that you can give me? So what can you do is, you can say, okay, if this guy is 1111 and this guy is 2222, for example, 2.1.1.1, for example. So that is 1.1.1.1 and 2.1.1.1. Will he communicate with him? No, right? Why? Because they both belong to a separate IP subnet. The first rule of two devices to communicate with each other is that they must be in a same layer 2 domain, same IP subnet. So if these two devices want to communicate with each other, they must have the same IP addresses. They must belong to a same layer 3 network, right? So here if I say 1.1.1.1 and here if I say 2.1.1.1.1, they both belong to a separate IP subnet, right? They will not communicate with each other. But he's a guy like me, he's a certified ethical hacker, or he's a normal networker person, right? What he will do is, he will go silently on the purchase department and he will say, oh, let us see what is the IP address of you, IP config, and he knows, okay, he belongs to the first network. Okay, so what he will do is he will simply go and assign his device a static IP of one something, one dot two dot, sorry, one dot two, for example. Now what did I do? I gave him an address of the same network of that device. They are communicating, right? So the management says, we told you to keep these devices separate, but our data is being leaked. What can you do? There is someone who is taking out the data. So what you can do is, even if you put them in a separate IP subnet, but they have an option, even though Microsoft allows you a lot of security features with group policies and all, but if somehow this guy gives an IP address with this domain, he becomes a part of this subnet. So what you can suggest is, okay, what we'll do is we'll take these devices over here and we'll plug this device over here like this. So he is totally isolated from this network. But if you say, I have a medium size corporation and there are only 40 employees, 40 people and 4 devices and 4 floors, for example. Every floor, there are 10 people who are sitting and you require 4 switches. So you will need 16 devices. I have seen some people working in a corporation. Some non-technical people don't even understand the difference between your electric switch and Ethernet switch. They will say, yeah, this is a 6,000 rupees switch in India. He says, which type of switch is so costly? But they don't know what it's an Ethernet switch. It is not an electric switch.
So here using VLAN or what?
Yeah, here we are talking about virtual local area networks. So what you can do is you can separate the broadcast domain using the concept of VLANs. What is a VLAN? A VLAN is a virtual local area network. Virtual local area network, and one VLAN is one broadcast domain. So layer 2 separation of your network here, even if now what we'll see is this person over here will be in one VLAN and this person over here will be in another VLAN, right? So what will happen is these 2 devices will not be able to communicate even though they belong to the same IP subnet. No, they will not be able to communicate, and that is a very good solution. You can say, so even if he comes in and he gives himself an address from that range, even though you say he is 1.1.1.2, but he belongs to a separate VLAN, the switch will do the second job of it. He will take the forward and filter decision, and he will not allow frames to be passed from one VLAN to another VLAN. Inter VLAN communication is not allowed by default. Let us see how do you do that. Let us take a switch and let us take 2 PCs, assign them first the same network address range. They will ping. The moment I create a VLAN and then I put this device into another VLAN, they will not be able to communicate. Let's go ahead and do that. Let's say this is 1111 and this is 1.1.1.2. Yeah, so the communication happens fine. The communication is happening now. This device is pinging with that device. What we need to do is, see, there are 2 things always. One is to create a VLAN. First job is to create a VLAN. Even now, actually, if you don't create a VLAN, these devices are so good, they will automatically tell you that there is no VLAN. I will create a VLAN for you. And first create a VLAN. Actually, this is not a mandatory requirement, but it is always good to do that, because if you are working on Nexus or other devices, anywhere, it's a good practice. And second time is to assign ports to the VLAN, particular VLANs. So how can you create a VLAN? Now creating a VLAN can be of 2 types. I will show you both the ways. You should be in the global configuration mode and you can say VLAN any number. By default, there is VLAN number 1 that is always present, and all the ports belong to all the ports are in VLAN 1. You cannot change the name of the VLAN. That is, the name is default VLAN, and you cannot also delete it. So by default, there is a VLAN already present and the name of it is default. You cannot delete it or you cannot change the VLAN. Now the VLAN addressing range is actually 2 to the power of 12, you can say 4096. Actually, you can create these many VLANs, but there is a reserved range. For example, you will not be able to use the range 0. You will not be able to use the last number 4095 and all. There is separate rules. So by default, VLAN number 1 is already present. There will be VLAN number 1001, 1002, 1003, 1004. Like that, they will have extra VLANs also. Let us see what is the reservation. How do you check that? Show VLAN brief. See, 1000, the first VLAN is there, 1002, 1003, 1004 and 1005. These VLANs are already there and they are for backward compatibility. Fiber distributed data interface, token ring, PDNet, and these are the ones. You cannot also delete this as far as my knowledge goes. So show VLAN brief tells you that there is VLAN 1, this is the name, status is active and all the ports belong to this VLAN. Now simply what we will do is, we will take this F0/2 port and we will put him in the other VLAN. How do you do that? Configure terminal. You can say VLAN 2, I created a VLAN and you can give it a name. Production. You can come out. This is how you can create a VLAN and you can give it a proper name. Now, creating a VLAN is done. Now, putting the interfaces, interface F0/2. Now, there are two types of interfaces. You can say this interface that is on the access layer. This interface is on this segment here is termed as an access port. This port is termed as an access port. So this is a switch port, layer 2 switch port. I will say switch port mode is access and switch port access VLAN 2. If you notice on the backend side, this layer is going through conversion. He is converging. He has kind of flipped the interface. So now let us see. Earlier this device was communicating with him. Now he will not be able to communicate with that device. See, now ping does not happen. Why? Because the switch takes the forwarding decision. He says show MAC address table. He says there is a device in VLAN 2 and this is his MAC address. If two devices want to communicate with each other, they should belong to same IP address, and now the new requirement comes in that they should also belong to the same VLAN. Even if they have the same IP addresses, they do not belong to the same VLAN. So this switch is taking the filtering decision. How does he do that? The moment a frame enters inside, the switch adds a VLAN tag to the frame. There are two types of tagging mechanisms. One is 802.1q tag and there is ISL, inter switch link. 802.1q. Why does it say 802? Because in February 1980, IEEE came up with the first standard. That is why we start with 802. And there are standards for it. .1q is the one for trunking, you can say, or VLAN tagging. ISL is inter-switch link. This is Cisco proprietary, and Cisco itself is not shipping its devices. ISL is not used. So you don't have to worry about any other trunking mechanism as of now. Only ISL is going to be the one that is supported over here. Because ISL changes the frame. ISL used to add a 30-byte header on the frames and it used to recalculate the CRC. That was processor intensive, you can say. So they have discontinued shipping switches with ISL and now they are going to use ISL only industry standard. If you are using industry standard, means you can combine two vendors together. No worries. You can use a vendor from one company, but we'll discuss that later on. It's like you have separate, you have a school, and in school you have separate classes. They have a yellow class, red class, blue class, green class. People wearing the yellow dress belong to the yellow class. And if two devices want to forward data with each other, the switch will check, oh, this he does not have anything to do with the IP address. He will check the layer 2 frame. Do you belong to VLAN 2 or VLAN 1? Okay, do you want to go out to someone on VLAN 1? The broadcast will be forwarded inside the ports in this VLAN only. This broadcast does not cross over here. No, that broadcast is not sent out on the other VLAN. It is like a layer 3 IP subnet, you can say. You cannot cross the boundary over here. You require layer 3 intelligence. Okay, so what we will do here is, now we will put this switch into this VLAN and let us see, or else we'll add another switch. What I'll do is, we will go in here and we'll connect one more end device over here, and by default this will ping 1.1.1.1. this is 1111, this is 1112, and this will be 1113, for example. Which device should this guy communicate? He must be able to communicate with this guy only. Why? Because he by default belongs to VLAN 1. You can say that is a native VLAN. Ping 1.1.1.1. He is communicating with 1.1.1.1, but not with 1.1.1.2. Why? Because the switch knows a broadcast coming inside into VLAN 1 will be sent out only on the ports belonging to VLAN 1. The broadcast will not be propagated on the ports belonging to VLAN 2. Now what I'll do is, I will take this PC and keep him into the other VLAN. How do I do that? I can say configure terminal interface F0/3. Switch port mode is access. Switch port access VLAN 2. What did I tell the switch? Please take this port and put him inside the VLAN 2. Now, if I say show VLAN brief, in show VLAN brief, it tells me that there is a VLAN number 2. It's a production number we named, and these two devices. So a broadcast or communication coming on this port will be sent out over here only. Let us check whether this device is able to communicate. Earlier, he was communicating with 1111. Now, is he able to communicate with 1111? No. Can he communicate? Earlier, he was not able to communicate with 1112. Can he communicate with 1112 now? Yes. Why? Because the switch knows. Now, the communication is coming from VLAN 2. It will be sent out in VLAN 2 only. So it is on us to create a logical separation of our networks. And how can we do that? It's totally dependent on us. There is another method of creating a VLAN also. How do you create a VLAN? You can say you have to be in the privilege mode. You can say after enable T on this hash mode. This is the exact mode. This is the privilege mode. Here you can say VLAN database. And then you enter into the VLAN configuration mode. And here you can say VLAN, for example, VLAN 5 name IT. And you have to say exit after this. So this is the second method of creating, second way, but this is not recommended. The switch will clearly tell you, please try not to use this mode. Why? Because this mode is being deprecated. But in storage area network, we use this mode only. But as of now, let us go on this switch and let us say, I see the mode. This mode is the privilege mode. You can say here you have to say VLAN database, not in the global configuration mode. The switch clearly tells you, warning, it is recommended to configure VLANs from the config mode. Means the way you followed earlier. The method that you are using, this one is recommended. Please try to use that as much as you can, because this mode is being deprecated. Please consult the user documentation. So you try not to use this, but this is also another valid way of creating a VLAN. I can say VLAN 5 name IT. It is not yet added to the database. You can say the moment I say exit, it will apply and exit. If I say show VLAN brief, here is my new VLAN that is created. This is how you can create a VLAN also. Now, a very important thing to understand. See, there are two interfaces that belong to a VLAN. There are two interfaces that belong to a VLAN. Now, what I will do is I will say no VLAN 2. No VLAN 2 means I am deleting this logical local area network. Our virtual area network is being deleted. But what will happen to the ports that belong to a VLAN? It's like the movie Terminal. The guy lands in America or some country, and the country wherein he came from, the country did not exist at the time. So he was stuck in the immigration for a year or so. So let us see back. Show VLAN brief. What do you think? This F0/2, where should they go? As of now, do you see VLAN, the ports 1 and 2 and 3 in here? No. So where did they go? Understand very important thing. If a port, if an interface belongs to a VLAN and the VLAN is deleted, these ports will stop forwarding data. If you see over here, these ports are converging. They are in, you can say, an error decibel state, but the data is not being propagated. They will be amber always. Why? Because the VLAN that they belong is not existing over here. So you have to be very sure that you create the VLAN 2. If I say now, they will start converging, and in a few seconds they will start forwarding the data. So if I say now show VLAN brief, why am I emphasizing a lot on this one? Because there is something called VLAN trunking protocol, and that has a very dangerous behavior. It can automatically delete your VLANs if someone does a small mistake. And that time, if the VLAN is deleted, your whole network will go down in minutes. And 1 minute of production time is thousands and millions of dollars in big corporations. So we don't understand the depth of this, but as of now, later on, you will understand the importance of this.